Hello students, in this problem, it is given that electric field in a three-dimensional space is given by the expression minus xi cap minus y j cap. Then we have to identify the correct statements. So if we draw a three-dimensional diagram, suppose we draw diagram in three dimensions. Where I am considering the given points as y-axis, x-axis and z-axis, x, y and z-axis. And if I am selecting a general point having coordinates x, y, z, suppose I am selecting a general point having coordinates x, y, z. So for this general point, let us again redraw this diagram. So for a general points having coordinates x, y, z, it is given that the field is minus xi cap minus y j cap. So for any general point lying in three dimension, the field is minus xi cap minus y j cap. So we can say that the direction of this net field is exactly towards a direction which is perpendicular to z-axis. As you might imagine that this will actually form a circular shape. This will actually form a circular shape having center at z-axis. So we can say that the correct representation of such kinds of field lines, the correct representations of such kinds of field line will be a cylindrical diagram with the z-axis as the axis of the cylinder. So we can say that the field will be directed cylindrically inwards. The field on this three-dimensional region will be directed cylindrically inwards with z-axis acting as the axis of the cylinder. Further, for a particle having coordinates x, y, z, we can say that the force acting on the particle will be equal to q into E, which will be equal to q into root of x square plus y square. Now for a particle moving in circle, x square plus y square equals to a square. We can say that this force will be equal to qa, and this force will provide the necessary centripetal force, that is mv square by a. So from here we can find the value of v for a particle undergoing circular motion. On a circle of equation x square plus y square equals to a square, then speed of the particle will be q a square by m to the power of 1 by 2. And we can also conclude that the shape of the equipotential surface will be cylindrical, since we know that the field lines are actually along cylindrically inward direction with z-axis as the axis of the cylinder. So we know that the equipotential surface is always perpendicular to the direction of the field. So we can say that this equipotential region will be cylindrical in shape with z-axis again as the axis of the cylinder. This is our final desired result, that is option C and D. Thank you.